Hi, welcome to this Open Security Summit in March. This is the first of this week's sessions. I'm here with Timo, who's going to talk about a really cool tool he's open sourcing on Kubernetes and to help us to make sure that our images are secure and have a really good security posture. So over to you, Timo.
Thank you. I will share my screen. And you should be able to see my screen now.
Yep.
Yes, I'm a freelancing consultant, and one of my customers is SDA SE. And together we're developing the cluster scanner. What is short introduction into SDA SE, because that might be interesting to know why the setup is so complex. SDA SE is developing software which clients can run in their own environment, and software which can be run in clusters which are hosted by SDSE for customers. SDSE itself is an insurance startup which helps insurances to deliver good software. And that also includes, obviously, security. So that is a big part. So let us come to the solution overview. What is a cluster scanner actually doing? Very briefly, you are having a Kubernetes cluster, and in the Kubernetes clusters you are running multiple containers with multiple images, and the target is to report known vulnerabilities or misconfiguration to the developers, and also to operators. For operators, for example, the lifetime of an image might be very interesting to know. Is it needed that they have to patch an image? The initial vision in 2017 is this one here. We will later see that there is a lot of things missing in this image, but the initial idea is we have a trigger, for example, a nightly trigger or a deployment, and then we fetch all running containers and the images, and then we iterate over them and scan the image. Very simple. And you could do it, for example, with Docker PS or in a cluster like OpenShift with both you get pods and inspect and scan the image. You will see that it gets more complex. So what is the journey? This is a very small extract of the journey SDA SE went through. First, I started with Dependency Track. Dependency Track is a tool which detects known vulnerabilities in applications. And we started using it with the Jenkins plugin. That has some issues. For example, that you can't, that you have to raise the threshold. It's not, you can't accept a specific vulnerability in the Jenkins plugin. You always have to raise the threshold in case you want to accept the vulnerability so that it doesn't get reported anymore. So that is very, it's not nice. So then we use Defect Dojo. To do that, we were scanning the master branch. Now let's see. Let's take a brief look at a typical deployment pipeline, which I assume is there in a lot of companies. You have a developer pushing code to the version control system. Then you have a build and deployment server building the application or artifacts, putting them into an internal repository. Then you first roll it out on test, and afterwards to the production system. But when you do it in the build, when you detect issues in the build and deployment server, and you stop rolling out, then it, because an issue got detected, it doesn't go to the next systems. But what in case the developer patched a vulnerability? That's why he wants to push to production, and it stops because there is an other vulnerability raised. So this is about known vulnerabilities problems. So that highlights that from my point of view, it needs to be asynchronous. When you do these kind of things. So beforehand, it was in the way that the build server here was a notifier, I would say. So the build stops, and you get to know, you have to do something. But here we see that I had to change it in a way that the developers are getting notified and nothing gets blocked. So, for example, via Slack. Also, I figured out that it would be good to do the tests on actual images which are in production. So I started with Customize. Customize is there to dynamically create deployment manifests, and it describes what should be in production. Yeah, I think that is a good wording. Should be in production. And I actually used grep to detect the images in these configurations. But one thing we also have to take a look: master is not equal to production. That's why I said should. Maybe there are some processes like approval or technical issues which also will stop pushing something to production. Let's take a look. When we have the build and deployment and it's getting pushed to the internal repository, there might be a technical issue here which prevents the image in going into production. Maybe it's on the test system, but it's not in production. And then we have a gap here. And as a security person, I care about what is in production with a product, or let's frame it different. I care where production data is. So whenever there is production data, I want to have my security controls. But when the security control when the security check or scan, when the security scan is performed on something that should be in production here, but actually isn't, then my information is not correct. So I want to focus on this system here. I want to focus on the system which has the production data. And only what is deployed there matters for me. It's very difficult to understand by developers sometimes, because they say, I fixed it, and I say, yeah, you fixed it, but it's not in production. And the other case is that everything is working well, but there is this one person here, the product owner, for example, which needs to put his approval that the new artifact is getting deployed. But then he is maybe ill, or other tasks are more important, and then it doesn't get pushed to production. And then we have again this thing: there is something in master, it's already it's ready to getting deployed, but it's not going in the production system because of a missing approval. So that are the gaps I have identified. In case you see another gap, please contribute. You're very welcome to share your thoughts while I'm talking. Yeah, and when the approval is not there, it's not going to production again. That's what this picture highlights. Then I identified that customize is something which might change and is not always there. And I had to change it, and that was, I would say, the birth of that is when the cluster scanner was born. What we have here now is that I run the dependency check on images which are actually in production. That leads to some more false positive, but the false positive rate, the enhancement of the false positive rate is very low. So I can take that from my point of view. And again, the teams are getting informed through Slack. To get an understanding of the different scans, we have the application, the container operating system, and obviously underlying host system. What I care about is the application and the container operating system. With the cluster scanner, I don't take a look. Maybe we can also say here is Kubernetes in between. So the cluster scanner only takes care of the application in the containers and the packages in the container, not outside of it. In the current implementation, you might have some more requirements later for me for things scanning in Kubernetes or relating it to images, but that we can talk later about when you get a deeper understanding. So now we're talking about the different scans which are there. One problem which I experienced, which I saw solved, raised again this containers. So patching. When you talk about patching in containers, we first have to take a look about how it actually works. So you build a container image, then you start the container based on that image, and then you run the container here. And then you might build again. But this build is only important in case you actually stop the running container and start a new one. This here is a bit useless, especially when we take a look at the vulnerability lifecycle. I simplified it a lot for you. So what you can see here is that a vulnerability gets discovered by a researcher, and then a patch is getting published. Let's say for the glibc, a main component in a container that actually talks with the kernel. And here, the patch is there, it is in this build, but the container is not getting stopped. And that means we don't have this patch included in our production system. So what we need, based on this picture here, is a container lifetime. I actually saw the container lifetime as a good first indicator. But it turned out it's not a good indicator. Does someone of you has an idea why it's not a good indicator?
So you mean, in this case, you mean lifetime or life cycle of the container?
Lifetime. I mean the container lifetime. When you do a Docker PS and you see it runs since 5 days.
Well, I guess what you're talking about is we don't know if it's updated or not, right? Is that where you're going to? So at that moment in time, like I say, if you push a new image, I don't know if that's the latest version of the container or not, right? I don't know the status of that container.
Okay. Yeah, that is actually true. That is a problem I couldn't solve so far. That's, I would say, some kind of outlook. We actually tried to implement it. We didn't find a good solution for that. So check if just to highlight what we are talking about for others, you have image A and you have version 1.1.1, just to make sure that I understand you correctly. And then you have image A with the tag 1.1. It's not right. 1.1.2. And when you're running this, you need to identify is there a new version. Is that what you mean?
Yeah. So
yeah, okay. That is actually something I would like to have, but I couldn't find a good implementation of something which gets this done. In case you know something, I would love to hear about it, because the problem is that it's mostly not like this. First,
I guess the question is, are you creating like a graph of your containers and how they relate to each other, right? And the kind of stuff that is running inside of it.
I have. Let me first answer about this container lifetime, and then we can go back to your more advanced questions.
Okay.
So container lifetime for me didn't work because the cluster is getting patched so often that the containers are getting restarted due to the patching of the cluster. So that means when you patch a node, you actually have to restart all containers on it. So that's why the container lifetime itself didn't work. So that's why I went to image lifetime. That means I take a look at the build time of the image. I would say it's an indicator, but as you mentioned already, the better thing would be to get to know, is there a newer version of the image, which from my experience can be answered for images which you're creating by yourself when you're following the multi-versioning. But when you're talking about cluster components, so infrastructure or external images, say the simplest version is that they don't use this version, that they say I use version beforehand. But even more complex, sometimes they don't do it like this. They do this, and then they have developed versions here, so you don't know, so you cannot identify easily is this a production version or not.
Yeah, and I guess well, but on your model, right? When you say container or image lifecycle, when you push a new version, are you killing off the previous ones?
Yeah, maybe you even don't want to kill the previous ones because you use A/B testing or something like this.
Mm-hmm.
So it might be intended. Or an issue, yes, but it's not.
Yeah, and that's why I was asking if you now are already thinking in terms of your containers and your images as a graph, because we start to do that. So we have this project where we have lots of modules and submodules within our deployment. So we basically want to track which version of almost our deployment we were at. And in a way, the version is actually a combination of 10 submodules, right? And then we need to keep track of which one have changed or which one haven't changed. And then eventually the way we got there was to basically go at git commits and go at almost that definition of what is a release, right? For each of those and tag it. So from the tags, we can tell which version we are at a particular moment in time. And I think in this case, you want to maybe augment that to do the same thing for a live server. So you could create a graph that shows you, right, what is the status of each of the pods that you have and the dependency of the pods, so that when you push a new one, you can also see, well, that pod is now out of date, right? Which is it's actually a valid point, because you could have actually, in some cases, you might have containers that would last for a long time, right? You might have containers that, if they're very stable, they might actually long for a considerable amount of time, but we might have patched it, but it's not actually deployed in production, right?
Yes, hopefully you will try to rebuild it after some time. So that's what I'm trying to push to the developers and the operator and the operators, because you also want to patch the underlying container operating packages. So to have a container staying for longer than, let us assume, 30 days without getting patched might be a problem for you. Maybe also 5 days. You can define it in the way you want to. But when you don't do something for multiple months, I would say that is an issue.
Yeah, well, but even it depends, right? Whatever that window is, right? It's whether you are comfortable with having.
Yeah, exactly.
It could be an hour, right? It could be I could not be comfortable having an hour, right? Or it could be a day or a month, right? But I think, yeah, the interesting question is, how do you visualize the status of the image? But yeah, no, but cool. Yeah, continue, man.
Yeah, that is something I cannot answer the question. What should be the latest version? Right now, I'm in the status that I'm using the container lifetime, and I can highlight easy time to manually look for a patched version, for example, or to manually rebuild it.
Mm-hmm.
So that I can answer. you will later see that they will also be able to answer what is in the cluster at which point in time in the past. Yeah.
Cool.
Then there is another scan which I added, which is called JustUnless. So I scan for JustUnless images. JustUnless means it's created by Google. Mainly it means that you don't have the normal, let's say, Ubuntu or CentOS image in which you install your dependency. JustUnless means that you just install the concrete dependencies which you need to run the application. So that means when you have a Java application, there is no shell in the container itself, in the image itself, and you can that also has some complications, like you cannot debug so easily and other things. Depending on the application, you might want to have it or not. And when you don't have it, I at least want to highlight to the team that they don't have it. So that's why I'm having this JustUnless scan. I first started to manually assess all these things, but it's much better when it's automated and team are getting notified automatically. Then this is more an outlook. I tried to implement a Marvel scanner based which scans images. We identified some issues with that because there are some files which the malware scanner in standard images detects as malware, which then you have to remove from the list so that the malware scanners can scan all the other files. But this, I would say, is more in the backlog. And I'm scanning for root. I do know that in the deployment manifest you can enforce a user, but often it's already a good indicator, at least for self-built images, when they are running as root, there is something wrong. So you can at least once say, I accept this image running as root. And I made sure with the run as, let's say, user 1000 that it's running with a defined user in my production system.
Can you expand on that JustUnless a little bit? So what is that something you run after the node to remove stuff? Because that's just actually pretty cool.
Yeah, it's an interactive session, I would say. So let me quickly open up my JustUnless presentation for you. JustUnless container. I have a short version here. The short version is really a bit longer than you might expect, but let me see. First, you need to understand multi-stage builds. Are you aware of multi-stage builds?
Yeah. I know how that works. Yeah.
Okay, so multi-stage build means that you will have two stages in your Docker file. For example, you have the build one and the runtime one. And in the build one, you, for example, can create the jar, which you then copy. But you could also install dependencies in this one here, and then copy the dependencies to the actually, let's call it runtime. And you could also make it in a way that this is a Docker multi-stage build, but when you use, for example, Builder, you can use, I'm personally using Yum often, so you could use CentOS here also. And then with Yum, you install the dependencies without any other things you need directly into the runtime image. You just and this one here would be actually Sketch, so there's nothing inside. And then you in the other container you say yum install, and it goes directly in here. So you just have the components you need. As an alternative to use yum, we can take a look here. So you this is actually to highlight vulnerabilities. I don't recommend to use CentOS 5 right now, but you could also copy just the dependencies. So to your target image, you see here, this is the CentOS 5 is built, and then you copy it from the CentOS 5 image all the things you need as an option.
So is that a concept or is that a tool? That's I'm just trying to understand. Is that?
I would say it's a concept. It's Google DistroLess.
Yeah, because I was taking a look at DistroLess. So it's not something you run on top of an image to take away stuff.
Yeah, it's exactly the opposite. I also started 3 times ago when I hardened an image. I took away stuff. But the new way, let's say, is to only copy the things you actually need.
Yeah, which of course is the real power, right? Yeah, so you only have, so you start from scratch, right? That's the idea, right? So you start from scratch or start something very light and then only, okay. Yeah, but I was looking at the website, but they have some base distributions, right?
Yeah, they have some base issues, which
Python
images which you can use, yes.
Yeah.
And they are obviously already more lightweight than other images. And but they are a bit bigger than when you do it by yourself. So it means there's already more inside than what you need.
Yeah, but if you want something like Python or Docker or Java or some of the other things, right? .NET, right? It probably makes sense to use that version, right?
Yeah. What I meant is when you use the Google DistroLess versions, they are bigger than when you build a DistroLess image by yourself.
Yeah.
There's more inside.
Yeah, fair enough. But still less than even using.
Still less than in other images. Yes.
Yeah. Very cool. Good stuff.
Okay, and for sure, when you introduce this strategy in your company, you might want to check which images are at this status and which are not, and provide these informations to the team so they can decide is it okay or not.
Very cool.
Okay, well, that was.
If you go back to that thing, so what you're basically saying is that what you do is you run the checks, but then on this pipeline you're doing, and that's when you run the DistroLess, and then the malware check and then the root check, right?
We will come to the architecture in a minute.
Okay.
How it is getting started. This is just the journey we made through to give you a small insight on how you can improve. And it's also to understand the history, and then you will understand why some things are built like they're built. Because it wasn't obviously intended here in the start. The whole thing here wasn't intended. So that's why the architecture is not. That's why the architecture is as it is. Yeah.
Michael, do you want to ask that question, man? It's a good question.
Sorry?
Sure, thank you. Hi. So, I am a developer in my bond. So, what is the best way to start with this journey? Let's imagine an organization that doesn't know too much about security, right? They wanted to enhance the process. Should you select a brand new project to start, adding all the different elements within the DevSecOps, or should you adapt that to something ongoing? And the reason why I ask this is because developers have a very short deadlines as well. So adding, these kind of elements within the SDLC or within the development process might affect the deadlines if that's an ongoing project. I'm not sure you see my question.
Okay. Yeah, I understand your question, I think, because it's the developer has to do something, is what you say, right? And the question is, is it good to enforce that? That's why I'm using this approach here, this defect dojo. So what? Let me give you an outlook, a short outlook. So let's take a look here is let's take a look at DistroLess, because we talked so much about DistroLess. When I inform the developers about you are running an image which is DistroLess, then they have this documentation at hand. So it describes why it is important, blah blah blah, and also give possible responses. And one is avoidance, that will often not happen that you use another image. You can also mitigate it. In this case, you can use the distress image, or you can build one. But another option is that you accept it. And Defect Dojo gives you the option to accept also temporary, for example. You can say, I don't care about this now as a developer or a product owner. Please remind me in 1 month. And then you accept it temporary for 1 month, and in 1 month it will show up again.
Mm.
So they can decide when they want to take it.
Mm.
Does that kind of answer your question a bit?
Yeah, I think you did. Basically, my point of view was, a software engineering department starting with the DevSecOps journey. I know we can add tools for enhancing the projects like dependency checks. How do they start? Should they start with a brand new project that doesn't have too much overhead? Or should they start adding components to an existing and ongoing project? Let's say they have already sprints. Is it recommended to start with a brand new project, or adding the, how you call it,
I would start with a project which you're close to and which is happy to make these experiences with you. And that would, for me, the better. I would make it with this personally. Because for me, it wouldn't matter if it's a new one or an existing one. It matters that they are working with me together, and then afterwards they can spread it in the company that it's good and useful.
Got it. Yeah, that makes sense.
So in a new project, it might be a tiny bit better because you can more easily introduce it in the start, and they can plan that they want to do the effort. But in an agile way, you only plan for the next 2 weeks, right? So
yeah,
you could also say you plan sometime within the next sprint. So yeah, I would make it. For me, the more important point would be which is a team which is open for such new experiences.
Got it. Okay, thank you.
Okay. Yeah, now we come a bit to the architecture. I obviously talked about the architecture beforehand with clients of SDA, with architects from SDA, with my work student Philip. I think he's also here in the call. So with a lot of people. But I'm very interested in what you think in all possible options you can think of. So let's take a look at the overview. We have a running application in containers, and we have maybe in the cluster also infrastructure related containers, which are making sure that Kubernetes runs it all. These are actually the targets. So we need somehow to go an image collector, which collects which images are running right now in my cluster. Then we need to scan this image. We need, I call it image scanner. Then we have already identified that Defect Dojo or a vulnerability management system like Defect Dojo is important for us, and we somehow need to notify, for example, through Slack or through email. So we have Kubernetes. Actually, I call it cluster scanner, image collector. Then we somehow need to orchestrate the scans. So we need a cluster scanner orchestration engine. We need the scans itself, Defect Dojo, and I call it notifiers. So this is the context diagram, with not as a diagram, but as a list. So let's take a deeper look into the architecture and how it works. We have the environment. That can be a cluster like Kubernetes, in which you deploy in the future the cluster scan image collector, which collects the images running in the cluster. You could also enhance this to a Docker, just plain Docker Linux system, to gather the images. The main point is that your process is, and then I create a JSON file with the cluster, the teams, or to be more precise, the Slack channel or the email, and the images inside.
Oh, can you show what that JSON looks like?
Can I show? I actually haven't prepared it, and I cannot show production data. But as you're interested, let me briefly take a look, and I will write it down in an anonymous way.
Cool. So when you create this JSON file, is that as part of the build process?
No, this is the cluster scan image collector is a container running in the cluster. Let me forward. Then it will be much easier to understand. This is actually the image collector. So you have in the cluster namespace 1 and 2 with different images as you've shown in the start. Then we have an API server which knows what is deployed at the different namespaces and nodes, and then I fetch from the API server the deployment manifests, and I fetch which containers, which images are in there, and then I can push it to a GitHub repository.
And that's the JSON files that you were talking about.
That is the JSON file, exactly. So this is processing it. You see here, this runs, for example, once a day, gathering it, or every hour, depending on what you want. Then these deployment manifests are getting passed here, and then it pushes this.
Cool. What do you call that?
Yeah, I call it Cluster Scanner Image Collector. That's actually the first start here. That's this one here.
Yeah. No, that's very useful, because even just that is a great way to just capture what's going on in servers, right? In clusters.
Yeah. I think so too. I first didn't want to do it, as you can see here. I didn't want to have something in production because I was scared, because then I need to fulfill all the security requirements I give to the teams, because it is a powerful tool. But this didn't work for me for long with these customized querying. So that's why I had to say, okay, I have to phase it. I have to develop this cluster scan image collector. And then it push it is to GitHub with these all the information we are gathering.
Yeah. And at the moment you take a snapshot of it, right?
Yeah, the snapshot, yes, but you can do it as often you like, right? You can do it every minute, every hour, every day.
Mm-hmm. Cool.
Less than a day, I wouldn't say. Maybe even only once in a week.
No, you want to do it as soon as, very often, right? Because at the end of the day, and then the JSON, yeah, okay, go on. But then
but very often is a good thing.
Yeah, cool. All right.
Very often. I do it very often, yes.
Do you replace the JSON file?
No, yes. It's in GitHub, right? So it's not a forced push. You have the history.
Yeah, that's what I'm saying. But you don't have, basically it means GitHub contains almost what servers are running in production, and you can actually go back in history if you want. But
yes,
whatever's on the latest commit is what's in production right now, right?
Yeah, and when you have a registry in which you're only allowed to push and not to change, at any point in time, you can say at this, when a breach happened or whatever, you can say this was there in production in this moment.
Yeah. Sounds good.
You can obviously also create manually a JSON file, or you can scan. As I said, you don't need to run this cluster scan image collector. You can also in a cluster you can also somehow create your own for a Linux system which just has Docker. It's in the end just Docker PS grabbing the image and pushing it in this JSON format, which I don't show right now, but I will obviously show it in the future. Now we are having this directory, which is actually GitHub. And from GitHub, now we see what I also have to explain. This is asynchronous. So this runs, let's say, every hour or every 5 minutes, whatever you want. and we push it in GitHub, and then when you want to, you can start the scan process. So all these steps now need to run kind of in a synchronous way. So you have the dependency check. As I said, the dependency check when you run it on images, it will have some more false positives. So what I like to have is these global suppressions XML, which is getting fetched, in which you can define it for all clusters. Then you have the other scans which I showed already, lifetime, malware, and the other ones. And they are obviously creating reports. So they need to be pushed into the vulnerability management system. This is the one way. And then you also, the scanner itself here, the engine here, also needs to get back what actually is handled. Because when you have a false positive, when you have a false positive and the team marks it as a false positive, for me, that means it's handled and I don't need to notify someone because they took a look at it and defined it's a false positive. So when you have unhandled vulnerabilities, then again we have a directory in which we store all the information of the vulnerabilities. Actually, again, we have a JSON file. I need to take a look at the time to speed up maybe a bit. This where in Defect Dojo is it, because you don't want to, which test in Defect Dojo is it to give them the direct URL to the findings. You need to store the team, the environment. Environment for me is here, for example, a specific cluster. The image, and not just the version, you also need the hash to identify this is exactly this image and not another image. Some finding info and the scan status, because it might fail due to some reason, maybe out of space or whatever. And then you need a notifier. So the notifier sends out the notification to the teams, but all at once in the best case. One way is to do it via Slack. So as you can see here, we move this team here through the whole thing, and in the end we can identify the specific team which is responsible for that image.
On that suppression, that scanner bit, so do you run that on the commit of the GitHub repo?
Yeah. Right now it's here is one trigger.
Yeah.
And it starts the whole thing. Yes, for some scans, when we go back to the scans here, like the root check, you might want to do only when the image is changed, or when you deploy something new. But for now, it's a trigger which you can define how often you want to do it. It's a cron job.
Yeah, and I guess the big advantage of this is the fact that you are picking up which images are now out of date, right? Compared to the pushes that we have, right?
Yes, then we have different types of scans, I would say. So this one here and this one, the image lifetime and the dependency check, that needs to run daily. Or even more often, depending on your protection requirement. But these can change. While the distro-less and the root one, they won't change for an image which you have checked already. So you could, for example, cache the result because it wouldn't change for a specific image. That's what I might highlight in the next minutes also here. So why I'm talking, why I'm saying that some such things are already implemented is because I'm having right now an implementation at a virtual machine in Ansible. The provisioning is with Ansible, but we identified that this has some issues. For example, scalability. I cannot scale here. And as SDA SE is having more and more clusters, it takes longer and longer. And that's why right now we are in the process of making the whole cluster scanner itself an application, containerization, I would say, to run it in clusters itself to scale better. We took a look already at the image collector. You can see here on the picture that I also thought about what credentials needs to be there to actually fetch something. Now we are coming to the storage. When you take a look here, how all these connections are getting done. So we have the job orchestrator, which starts this synchronous process, and I then prepare the image. That means we first need to fetch it, obviously. So maybe you can see here is your image registry. You need to fetch it. Then you need to prepare the image. Somehow you need to extract the image. And in this case, we identified that the best is to pack it again, and then we store this image star in the persistent volume. And from there, we can run the scanners based on this image star, because we don't want to pull it again and again from the registry and have the different scanners, and put the scan results here together with the status JSON in other persistent volume, and then the job orchestrator can fetch the findings and aggregate these findings. This is because then it's easier to upload it in Defect Dojo with these generic finding implementation. And the other scan results, for example, from Defect Dojo, we can directly upload with the so-called Defect Dojo Defect Dojo client from the cluster scan and push it into the Defect Dojo. I'm actually using here, there is a tool called Secure Coach Box, and I'm also working together with them. What they have is a Defect Dojo client in Java, and I'm using that to I put that in the image, doing it a little bit more like extracting the test URL, and then I push it to Defect Dojo, and afterwards I can use a notifier to notify the teams. Yeah, it was a bit fast, but as we're running out of time, I will continue. The stored files are, as I said, the findings and the status JSON. I have identified with the current setup that it's hard to debug when issues are arising, like I can't pull images anymore because I'm getting close to the rate limit. That was very hard. So I'm putting this error also in the status JSON, and it could look like this in a simple way, that you just have start and finished, and when the status is not completed, you might have more. Also in here is currently planned to have the path for the dependency check XML, the scan results. We already saw the different types of scans. Job scheduling, as I said, it's not implemented for clusters. So right now we are thinking about how to schedule these different scans. Our, let's say, easy, simple approach, which might lead to issues, is that we just use Kubernetes. We push all the jobs in there and say you are only allowed to do three jobs at a time. But it might get we might get issues about the job status and the review, is it done or not. Another option we figured out is Argo workflows. So we somehow need to introduce ourselves into these Argo workflows, but it might also save some time because it has a job handling. So maybe that is what we need. In case someone of you has already experienced this Argo workflow, as you now got an overview of what we want to do, and you also know Argo workflows, please get in contact with me afterwards, so that we can talk about if this is the right approach, or we should stick to the easy approach here.
So yeah, so we actually use Argo's workflow quite a bit, right? And it is an interesting option for what you want to do here. Question is, which cluster are you running this on the production one or another cluster? I missed that.
No, this is actually another cluster, right?
Oh, okay, completely separate cluster, right?
On the production cluster, in the production cluster, you just need the image collector, which collects all the images, and then you have another cluster where you will run this application to scan the images.
Yeah. Then definitely, I think Argo workflows will help you a lot here, because the cost, there's a bit of performance, but it's not relevant here, right? Because I think in our case, it was, we were trying to use it for real time, kind of very fast execution. But for the stuff that you're doing, I actually think that it will give you, like you said, it will give you that visibility, but also will allow you to implement complex workflows, and also try to and allow you to see which parts of it are executing right. So yeah, absolutely.
Okay, thank you. So in case I have trouble to implement it, will you be open for a small talk about my problems then?
Yeah. Let's we can use the summit. There's a couple of people on my team that also have experience with Argo workflows, right? So absolutely, this is something that is worth exploring.
Then we come to we see we are coming close to the end. Now we're talking scheduling notifications. One thing is nightly, or that is something Denise already also recognized. Maybe you want to do it on a push, on a deployment. So you somehow get a hook in the cluster itself. Right now, the whole thing is more on the nightly. It's more triggered nightly, but let us take a look at the requirements I identified. A wish from the development teams is I want to get notified about all these things once. So one thing I had beforehand, without the notifier, is I having a task, a scan, then I push, then I scan and push the results to the development team. Then I scan the next image. It might be nothing, and then again nothing, and then again, oh, there is something. Then I send a message to another team, and then scan, and then again to the first team. So it's not. So they get it through hours, multiple notifications, and they said no, we just want to have it once a day, all notifications at once.
Yeah, definitely that, man. But I
but I had to experience it first.
Yeah. But I think that's a different problem, right? It's almost like, it's what you do once you have findings, right?
Yes, but it matches the current implementation of doing it, let's say once a day. Then I can also notify once a day, but all at once, please, is the message.
Cool.
I don't want to get notified multiple times per day. Also from ops uses, for example, the image lifetime to schedule patching that needs to be done once every X days. And then you have what you also have to take into account when you're on premise. Maybe in the night you are having resources available, a lot of more resources than during the day in a cluster. On deployment, as Denise said, that would be my personal wish for some of the checks, but I would say in total that will have to wait some time until we will be there. This is a sample event notification. I will speed up a bit because we are close to the end. You can give context information via labels. At least that's the plan right now. So you can put it in the deployment manifest. And then you use inheritance to override it. So on the global level, cluster level, you say this is a contact point. On the namespace object level, you can override that. With this, you might know that I'm the leader of the DevSecOps maturity model. of the overall opportunity model. With what I have shown today, you will get this mature. The right side here, patch management, is more indirectly as a security architect. I don't want to have these discussions with the teams. I want that they recognize by themselves that they need patch management and that they implement it by themselves. I don't want to be involved how they do it. I just want that they do it. So I indirectly give them all the information that they have to do it and think about it. And directly we are testing for virtual environments, that there is a root user used in images, or that they are not using JustUnless. We can test for malware. We have server-side components with known vulnerabilities, which we are testing. And when you take a more deep look, you will recognize that when you're using defect mojo, you will also get a lot of the consolidation dimension. In an outlook, in the short term, I will work on the cluster architecture, for example, with the Argo workflows. In midterm, I would like to add more scans, and for example, this plain Docker collector, I would call it. And in long term, I might think about Dependency Track, which is, I think, a bit better than Dependency Track, but there we need to identify how to keep track of the bill of materials, so that will be a bigger task and is not done in a few days. So, on time, I would say thank you for being here. In case you have more questions, recommendations, questions, please don't hesitate to ask.
Cool. I definitely think we need to do a follow-up session, right? And I actually think that so we're going to start a couple of we call projects at the Open Security Summit, and I think definitely a sort of a Kubernetes area where we also have lots of people that have experience in Kubernetes and can share some of these tools. I think it will be quite cool, right? But yeah, really good session. I think this is it shows that kind of workflows that we really need to start doing from an image management point of view, and a lot of the moving pieces that you need to do, right? So it's really cool, and it's open sourced, right? The project. You show the link
open,
there.
It will be open sourced, yes.
All right. Cool. Well, I'll do it sooner rather than later, man. It's always easier. Just just do it, and then we take it from there. Cool. Well, thanks everybody for participating. The video will be online in a couple of hours or day, and then I'll see you in the other Open Security Summit sessions. Thanks, Timo, for a great session.
Thank you.
Yeah, thank you. It was cool.